Hello, dear viewers. How are you doing today? We are in week 2 of the MLOps Zoomcamp, and the objective of this function is to get familiar with an open source package called as MLFlow. So MLFlow is basically used when you want to track your experiments and manage them through a centralized server. So the objective of this week's homework was to perform some logging into this remote server and get the results out of it. More or less, it was from the perspective of getting familiar with how ML flow works, and I'm pretty confident that this introduction is enough to set a ground for rest of the students to use it in their machine learning projects. So let's get started. I have opened VS Code here, and there are some scripts which were provided by the MLOps course itself. Uh, in the homework, we were required to make some modifications to the script, and uh, we were asked to produce the outputs as it was mentioned in the homework. I will go through all the scripts individually, and I had faced an issue of running the ML flow server in WSL, and the fix for this problem is to run ML flow within WSL, then establish a SSH connection through Windows machine, and then get the browser visible in Windows 10. That is my operating system, right? So let's get started. I have made the changes in the script, but the next step is to show them in the browser. And for that, I have to switch to the remote server, right, which is available within Ubuntu. So what I'm going to do is I'm going to connect to host and type here name of the machine and the IP address. So this IP address can be found out by typing IP, it's if config, right? And this is the address of the server which is running in WSL. So I'll click on it. A new instance would open up, and here we would see the machine which is running here. All the steps of establishing SSH can be easily found out through any tutorial on the web. uh, And I'm going to navigate to my project directory, MLOps Zoomcamp. Okay, so the workspace has loaded. I will first of all activate my environment. Yeah. Also navigate to the week2 directory, right? So the first script here is the pre-processed data. What this script basically does is, um, first of all, you have to download the data set. So in the previous videos, we have used yellow trip data taxi, yellow trip taxi data, but in this assignment, we have to use green taxi data for the months of January, February, and March, right? And I've placed these files within the data folder under this particular directory. And this script basically transforms the data set. It transforms some data set, calculates the duration, right? And at the end of the script, what you get is some pickle files, which are nothing but the dict vectorizer. And there is also train, test, and validation data set, which are written as pickle files within the output, right? So to run the script, what you have to do is specify the path of the script. This is pre-processed data. There is a parameter called raw data path. So this basically signifies the location of where your data resides. So it is in our data folder. The other option here is dest path, which is nothing but the output location, right? So we'll specify that. Even if you don't specify it, it will automatically create, right? So once this is done, hit enter. So I have already created this file, so you may not see everything from scratch, but this is the output you might get. So there is no MLflow logic involved here. This was just to set the ground for other assignments, for other scripts, right? So the next step is the train.py file. So what it does, so the requirement here in this particular script is to basically use auto logging feature of MLflow. So MLflow is compatible with with all the popular machine learning frameworks such as scikit-learn, XGBoost, TensorFlow, Python, etc. So what you can do is you can use this function like autolog, and it will automatically log all the uh, validation data set, training data set details. It will also log the parameters that have been used for your model, and it will also log the metric that is used to evaluate the performance of the model, right? To run or to log anything within MLflow, you have to insert that logic within a context manager, and that can be done using the with keyword of Python and this particular line mlflow.start run, right? And place all your logic after this thing, start run, and MLflow will start logging it. But to do that, there are a couple of steps, right? So you also have to specify the logging server details. So in our case, we are using SQLite database MLflow. I mean, I have given this name as mlflow.db, right? And this is what you get here, mlflow.db. So when the server runs, it will load all the model artifacts and hyperparameter data from this database, mlflow.db. This name can change. If you're running this in Azure or AWS, at least for Azure, I know that the tracking URI is by default given in your workspace, so you don't have to set up another server, right? And the next step is to set the experiment. So here I was just trying out things, so I have given the name MLflow homework, right? It can be anything. So all the runs of a specific experiment will be shown under the name of the experiment that you specify here, right? All you have to do is import MLflow, state the start run, so that MLflow knows that some logging will take place from this function. And I don't need to specify something like this, MLflow dot log param, or let's say in our case we call it metric, right? This would come here. Here I can specify name of the metric that I want to log and the value, right? So instead of me doing all these things, everything is taken care of by this auto log. So I'll remove this thing. Okay. So I'll run the script now, and the way to run this script is like this. Yeah. So you type MLflow UI, and this will basically open up the browser, and then the backend store URI is nothing but name of the um, flag that we are going to pass, and this is the address that we have set in the tracking URI, right? This one. So if I click enter, so this is running. I can either click here or here. There's one more step. It's called port forwarding. We have already added 5000 here. And if there's any other port that you want to forward to your host operating system, you can specify here, and we'll be able to uh, open it in the host operating system. So I'll click this link. Yeah. So MLflow homework. What you see are rest of the experiments that I have performed. They are also listed here, right? So you can see the name. This is a randomly generated name. You can also specify a name through the parameters, right? When it was created, how many seconds it lasted, what was the source or the Python script in which it was used, and what particular model is being used here, right? What framework, sorry. And when I click on it, I get some details like the parameter details, bootstrap, CCP alpha, criteria, max depth, so on and so forth. So the first part of the homework was to identify what was the max depth, and you can see the max depth is 10 here, right? So that's how the homework was. It was just to get enough information. And here also you can see the signature of the model, like what was the input used here, and all these things, right? And if you want to uh, make inference out of this, you can copy this Spark data frame code, or there is also Pandas data frame, and use it in your inference logic, right? Yeah. Let's now go to the second section of the script. So once the train was done, you can use hyperparameter optimization to find out what are the best set of parameters for this particular data set, right? So here I have set the experiment name as random forest hyperparameter optimization, right? This is what it stands for. And I'm also required to install another library called Optuna, which is used for hyperparameter tuning. Yeah. And the model that I'm going to use, or what is being asked to use in this assignment, is random forest regressor, right? So all the output files that we have created in the pre-process script file, they will be referenced here. So in the last run, we looked at MLFlow.sklearn.autolog, right? In this, we are manually going to log parameters. So the exercise also shows you how you can auto log these things, but if you, let's say, want to only want to log some specific things, then you can do it manually, so right. So there is this objective function that I have, and here there are some parameters which are defined in the search space of this hyperparameters. So if I just want to log all the parameters, I can specify like this mlflow.log params and specify the dictionary here, right? So this was the dictionary that was used. If there is only one parameter, like let's call it max depth, then I would just have to, pass in max depth, and it would be log params and the alpha value. So I only needed to log parameters, so that's what I did. The next step was also to log the metric whenever the several jobs within this hyperparameter tuning process got started. So I'm also logging the RMSE metric for each of these logs. Yeah? And I simply executed the script. I'll not show the executions because I've done that already. So instead we'll go to the uh, experiment and look at the results, right? So here I did the hyperparameter optimization, and there are several columns that you can also have. Let's say you want to have number of jobs, number of estimators, or max depth. And apart from this, you also want to have the RMSE. So let's take a look at these things, right? And you can also change, or you can also sort the metrics here. Just click on these values. So this is the highest RMSE. Error should be less. So I'll start with this one. So we can see for this RMSE, what were the parameters that were used, right? Like this. And to get more detail, just click on any of these runs and you can see it like this. Now let's go to the last part of this week homework. So once you have identified what were the best parameters, what you can do is retrain the model and register the best model so that it can be used in production. So same things here, set the tracking thing, set the experiment name, right? MLflow autolog you can use, but I think I did not use it. Yeah, it does say autolog, but I made all the things, all the logging manually, right? So again, I'm making use of all the outputs that we generated in the first part of the script, And on top of this, once you execute uh, the script, what you get is the best model, and you can also register this model right through the GUI app. So I'll actually run this script to see how the output looks like. So let's go back to our script, get rid of all these things. We only need register model, right? This. So it's basically printing out the best runs, or each individual runs first. We have specified only 5 runs here. Yeah, 5 runs. By default, only the 5 runs will get executed. So 1, 2, 3, 1, 2, 3, 4, 5, right? So out of this, the best run was this one, which had the RMSE 2.44 on the test data set. Now let's see how this would look on the MLFlow UI. Okay, this is the same MLFlow UI that we saw last time. So I'll click on best models. Here I can add more columns like test RMSE, validation RMSE, and so on. Right. Once this is done, I can sort based on the test validation RMSE. So this was the highest, this is the lowest, right? And also the corresponding validation RMSE. If I want to use this model, if I want to use the details from this run, I would click on it, and there I get the option of register the model. Right? I can see everything here. So when I click on register model, so let's create this. Let's give it YouTube RF classifier, just some imaginary name for this demo. And once this is done, I'll click it here. Yeah. So I can also specify what stage this belongs to. So I can make it transition to production. Yes, transition to production. Okay. So you can see that the stage is now being made to production. And if I click on the models tab on the MLFlow UI, I can see a list of all the models that are registered, and I can also see what stage they belong to. So this was the one we just created, and it's in production, right? So you can apply filters, and with tags also you can find them quite easily. So that's how the models tab works. And yes, that is pretty much it. So all these things we were required to do. There is also a couple of things that you can do on your own. You can set a description through the UI as well if you want, or you can do this programmatically using Python. And tags also you can add. In case you forgot to add from the Python script, you can do it manually uh, for this model that you have registered. So that's about it for this week's MLOps Zoomcamp video. It was a wonderful experience to use MLFlow for tracking, and it makes sense to use MLFlow in all your experiments that you are doing if you have a bigger team. So thank you for watching this video. I was late to produce this video because I got caught up in my day job. I was part of a hackathon that lasted over a week. So this video may not be up to the mark, but I have tried to recall and summarize all my learnings so far here. And also I have written a blog. You can also find the link of it in the description below. Thank you for watching this video. Have a nice day.